figure shows the graph of velocity versus time for a particle going along x-axis. Find acceleration time graph. So the acceleration, find the acceleration first. So what will be acceleration? This is what kind of graph is this? Velocity versus time graph. So velocity versus time graph, if we see, figure shows velocity. Okay, नहीं, कुछ और है, क्वेश्चन गलत डायग्राम आ गया. Figure shows a velocity versus time. This is acceleration versus time. एक मिनट, इसका डायग्राम दूसरा वाला है, ये डायग्राम. कोई और डायग्राम, एक मिनट, इसको मैं छोड़ दे रहा हूँ, दूसरा क्वेश्चन ये करते हैं. This question. Okay, so this question is what? Figure shows the graph x of x coordinate of a particle going along x-axis as a function of time. Find the average velocity during 0 to 10 seconds and instantaneous velocity at 2, 5 and 8 and 12 seconds. So first we will find the average velocity. So average velocity, for finding average velocity, what we are going to do is total displacement by total time between 0 to 10 seconds. So the position at 10 second minus position at 0 second, that will be displacement divided by 10 minus 0. So this is the thing which we are going to do for part A, the average velocity. Average velocity is indicated by this kind of symbol. Okay, so x10, the position at 10. So you can see at 10 the particle is at 100 meter. So you can write 100, and at 0 the particle is at 0 position. 100 minus 0 by 10. So we are getting 10 meter per second. So this is the velocity average. Now part B, instantaneous velocity is 2, 5, 8 and 12. So at 2, if we see, so 2 is lying here, 2 is lying between 0 to 2.5 region. So velocity at 2 equal to 2 seconds. Velocity will be what? So here also the velocity can be found by getting the slope of this graph, that is slope between 0 to 2.5 seconds. So that is what? Slope from t equal to 0 to t equal to 2.5. So this is the slope. So how do we write the slope? The change of position. So 50 to 0. So 50 minus 0, and in how much time this displacement occurs? 0 to 2.5. 2.5 minus 0. So how much is that? 20 meter per second. Second, it says between at 5 seconds. So 5 seconds is lying here. So 5 seconds we need not to calculate, because we can see from the graph itself, the slope is what? 0. The graph is horizontal at this point. The position is not changing at 5 seconds. The slope is 0. Graph is horizontal. So velocity we can directly write as 0. No need to calculate. At 8 seconds, t equal to 8. So 8 is lying between this point and this point, means t equal to 7.5 and t equal to 10. So how do we write velocity here? The change of position. So that is 100, and here it is 50. So position is changing from 50 to 100, and the time is changing from 7.5 to 10. What we can write is 50 by 2.5. So again we are getting 20 meter per second. Now at t equal to 12, where t equal to 12, 12 is lying in this region, here, somewhere here. So that is this part slope we need to find, this part. So for that, what we are going to do is the change of position. So final position is 0 and initial is 100. So 0 minus 100, and the time has changed from 10 to 15. So 15 minus 10. So that is 5. So minus 100 by 5. So minus 20 meter per second. So these are the velocities at different points of time given in the question. So this is VT. So VT graph. तो VT ग्राफ देखिए 0 से 2.5 and 2.5 से 7.5. 0 से 2.5, 2.5 to suppose this is 5, this is 7.5, this is 10, this is 12.5. So 2.5, 0 to 2.5, how much is that? That is coming 20 meter per second. So this will be 20 and constant. Slope is constant. So uniform motion. So it will be like this, 20. And then 0 from 2.5 to 7.5. So graph will be like this. Graph will be like this. Then from here to here, graph will be like this, 0. And then 7.5 to 10, again positive. This line need not to be drawn. So it is again positive. Then from 10 to 15, it is again negative. Minus 20. So graph will be like this. So we can convert the position time graph into velocity time graph in this way. And velocity time graph is most important and most frequently used graph. Why? Because velocity time graph, on one side if you take the slope, it gives acceleration, and other side if you take the area, it gives the position. So velocity time graph is used more frequently. Okay, so I am giving a velocity time graph and you have to draw the